Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we saw the difference between the normal distribution and the t-distribution visually. We noticed that the t-distribution had to be used in cases where we had some uncertainty, meaning we didn't have the variance and we had actually instead an estimation of it, which meant that we had to introduce the degrees of freedom as the measure of how much independent randomness is left after we estimated the parameters, due to that uncertainty that now came because we had an estimate of the variance and not the actual variance. We also agreed that fewer degrees of freedom meant that we had more variance uncertainty, which meant we had to be more cautious, and that also translated in heavier tails. However, there is something that happens when the sample size increases. Most of you definitely have read in papers how a limitation of a particular study is that there's not enough data or that the data sample is very small. So what actually happens when the sample size grows, and why do we like the sample size growing in terms of like this uncertainty that is produced due to the lack of the variance? So as the sample size increases, what happens is the degrees of freedom also increase. It means that our estimate of the variance becomes more reliable. Okay? Which means that uncertainty about the variance is shrinking. So visually, the t-distribution should slowly collapse into the normal distribution as the sample size increases, which means that from this original red line that we have here, as the sample size increasing, the tails should become lighter and the distribution a little bit taller. And if we keep repeating the same thing as the sample size grows even more, we'll see that it will keep on shrinking the tails in here, so it becoming thinner while becoming taller until it finally like coincides with the actual normal distribution line that we have in black and that I just highlighted now in pink. Okay. So in large samples, the t and the normal distribution are basically the same. This is also how asymptotic theory works. So for any one of you who in their materials has a particular lecture slide or chapter dedicated to asymptotic theory, know that this is one of the reasons why you need to go through the chapter of asymptotic theory to make sense of why are you using all the different distributions you're using when you know that you don't have the variance, but you're using estimates of it. Now, why econometrics uses the t-distribution? Again, in econometrics, variance is almost always estimated. Samples are often not huge, so we always default to the t-distribution. So the key takeaway that you should get out of here is that the t-distribution is the price we pay for estimating the variance. Now, the t-distribution exists because the variance is estimated. Okay, because under the normal distribution, then we had the variance known, but the t-distribution assumes that it's estimated. How does this relation between the t-distribution and the normal distribution translate into the actual table numbers that we see? I'm not going to explain how to use the t-table yet in this video, but I have taken the top part of the t-table and the bottom part of the t-table just so that I can also show you with the numbers this idea that the larger the sample size, then the t distribution is collapsing into the normal distribution. So everything that you see inside here, these are your t values or your t scores. On the first column in here, as you can see, you've got the degrees of freedom, and they are increasing as we go down. So degrees of freedom starting from 1, 2, 3. So as that number keeps increasing, it goes here to 1,000. In most of the tables that you will have access to, instead of writing it as Z, sometimes in here it will just be infinity, just to indicate that the sample size is very large. Okay? So this is the line that it's basically highlighting the fact that the T distribution has collapsed into the Z distribution. So this is the line that hints at collapse of T distribution into Z distribution. Okay? Which what happens is that most of the times, instead of using the t-scores that you have in here, you use the standard z-scores, assuming that the sample size is large enough. I hope this dispels a little bit of the confusion, why sometimes, even though you're using the t-scores in your hypothesis testing or in any exercise, you actually end up just looking at the last line in here, or just using some very standard values of Z scores that you have memorized, like the 196 in here, or the 164, the 257 in here. We'll see in another video where all of these numbers come from and what do they mean. But for now, I hope this has cleared out a little bit the relation between the normal distribution and the T distribution, both visually and in relation to the table, and I'll see you in the next video.